Hello बच्चों, today we will discuss the questions of today's mini mock test 1. Now in today's exam, if you see the chapters which were, the first chapter was amines, the second chapter was biomolecule, the third chapter was isomerism, fourth chapter was nomenclature, fifth was general organic chemistry, and the sixth one was hydrocarbons. So student, let's discuss today's question paper. Now here's child, I think so you can see very clearly on the screen question number 1. Acetamide is treated separately with the following reagent which would give methylamine. Now before you start anything child, the first thing what you should know is what is acetamide. What is acetamide? Now see, what is the structure of acetamide? From the name itself indicates, first it's an amide. Yes, so basically you write amide like this, C double bond O and NH2, and since you should know that you have got a word called as aceta, that means it indicates 2 carbon atom acid, so it's a 2 carbon atom amide. So this compound is known as acetamide. Now this is that acetamide compound. Now what they have told in the question, that this acetamide when treated with something, the product obtained is methyl amine. Now basically if you remember child, this reaction is what? Where you can see your primary amide is getting converted to primary amine. That means what is happening with one carbon atom? Less. And you can see very clearly child that one carbon atom is missing or has been removed. And I think so you remember child, one of the reaction where your one carbon atom becomes less, I think so that reaction is known as Hofmann bromamide degradation, where the reagent used is halogen, and along with that you require a base. It can be either a KOH or it can be either an NaOH. So as per our discussion, the correct answer for this MCQ is nothing but option B. I think so student, is it clear? Let's move to the next question child, what we have on the screen. Now over here the question is something like this, which of the following amines will not react with nitrous acid to give nitrogen? Now basically what is this reaction? Let's first understand. Now whenever if you have got an amines, basically I am talking about a primary amine. Now when a primary amine is treated with nitrous acid, basically what happens? Now see, we are not studying a mechanism in detail, but yes, I have told you in the lecture that whenever there is an amine and you have nitrous acid. Now what is the open detailed structure of an nitrous acid? It's something like this, and I have given you the logic to remember this. This bond breaks, this bond breaks. So here you get product and byproduct. What are product? The product is nothing but you get an alcohol. The byproduct what you get is nitrogen gas, and one more byproduct what you get is alcohol. That means in this reaction, have you noticed that when a primary amine is treated with a nitrous acid, we get alcohol and a nitrogen gas. Can I use this reaction as a laboratory test for identification of primary amine? Because no other amine other than primary will give N2 gas. So as per our discussion, they are asking which will not react. Now I think so this is a primary amine, which you can see very clearly. So this cannot be the answer. This is also a primary amine. This cannot be the answer. Yeah, this is also a primary amine child kid. This is not the answer. So the correct answer is tertiary. That means your tertiary only when treated with nitrous acid will not produce a nitrogen gas. That means the correct option for this MCQ is D. Kids, let's proceed with the next question than what we have on the screen. Now child, I think so on the screen you can see very clearly the third question, and what it says, primary amine can be distinguished from secondary and tertiary amine by reacting with which compound or which reaction? Now basically bacha, when you have studied amines, you must have been knowing that in amines chemical reaction we have got laboratory test. Out of that laboratory test, if you remember, one test is known as carbolamine test. Now basically carbolamine test is used for detection of only and only primary amine, and the reagent used for carbolamine test is a chloroform, and along with that you require a base, either it can be a KOH or NaOH. So this is that reagent condition for carbolamine test, and I think so they have made it very clearly that which reagent among the following can be used to distinguish a primary amine with secondary or tertiary. The correct answer, I think so, for this example has to be option A. Is it clear, child? So please remember, carbolamine test is basically used for detection of primary amines only. So here I think so this question is clear, child. Let's proceed with the next question, kid. What we have on the screen. Now child, this is nothing but a reaction where you can see you have to identify A, B, C and D, but finally we want our D product. Now let's see what is this reaction. Now if you see a child, the starting material given to us is nothing but an benzene which contains NH2 group. Can I call it an aniline unit? Now when you treat this with NaNO2 and HCl, I think so this reaction what we know is something called as diazotization, where diazonium salt will be formed. So where your NH2 group gets converted to N2 plus and Cl minus. This is what is happening during this reaction. So can I tell the product A will be a benzene unit containing N2 plus and Cl minus. So our compound A is benzene diazonium chloride. Now this compound is further treated with cuprous cyanide. Now when you take this cuprous cyanide, basically this reaction, if you remember, is known as Sandomir reaction, where your N2 gas will get lost, your Cl will go with this, yes, or you can do one more thing. One thing is not given, otherwise the more appropriate reaction is what? Along with the cuprous cyanide, you have got potassium cyanide. So here what happens? Your K and Cl will get lost, and that CN will get attached to a benzene. So here what are you going to get is nothing but cyanide group will be attached to a benzene. Can I name it as cyanobenzene, or can I name it as phenyl cyanide? Now what? What is this? Is nothing but my component number B. Now what is next step? I think so the next step is treatment of this compound with H2 and nickel. Basically H2 nickel is generally used for what? Hydrogenation. And I think so we have studied cyanide always on reduction gives primary amine. So here can I have now last step, benzene ring containing CH2 and NH2. So can I call it nothing but an benzyl amine, which is nothing but my product number C. And what is the last step, child? The last step is treatment of this compound with a nitrous acid. And basically what does nitrous acid does? We know that this nitrous acid does what? Your amine group will get converted to an alcohol, which you have I think so done in the previous example only. Is the term clear? So what should be your final answer, child? It should be a benzene ring containing CH2 with an OH. Can I name this compound as benzyl alcohol? And I think so they have asked us what is D, and as per the option given to you, you can see you have got an alcohol over here only. Is that term clear? And which is nothing but our product. So I think so you have understood this answer. Let's proceed with the next question, child. Question number 5. Now, in question number 5, child, what you can see is they have given as examine the following two structures for anilinium ion and choose the correct statement for the one. Now, there are 4 statements given to you. Now, if you see, second structure is not an acceptable canonical structure because carbonium ion are less stable than ammonium ion. Now, this is, let's see, read. Let's take the second statement. Second is not an acceptable canonical structure because it is non-aromatic. Okay, we'll even just see and justify this. And the third statement, if you see, is second out of these two, second is not an acceptable canonical structure because a nitrogen has got 10 valency. See, nitrogen having 10 valency, that means you should know one thing which I have told you, that nitrogen can never form a pentavalent state because it is belonging to a period number 2 and hence the maximum it should stretch as 8. So, here in this example, if you see the second one, you can see this nitrogen atom contains 5 bonds. It is a pentavalent state and I think so nitrogen cannot form pentavalent bond. I think so. So, which statement I think so should be correct in this? It's nothing but C. Is the term clear? So, this example should not be a difficult, it's a basic. Let's proceed with the next question, child, what we have. Now, in the next question, child, if you see, I have got one reaction and on the arrow it is given as nitric acid plus sulfuric acid. I think so this reaction is called as nitration. But before going for nitration, let's understand, do we have got over here and ring? Obviously, this is something called as aromatic ring. Now, before we start aromatic ring, there are certain things, that is what? First, benzene molecule likes to undergo electrophilic substitution reaction. Is it correct? And this electrophilic substitution reaction can be written in an abbreviated form as ARSE reaction. Is the term clear? Now, this was the first point what child you should know. Second important point child you should know is, I think so if you remember, there are 2 types of groups in nature. One is electron donating group and other one is electron withdrawing group. So, over here suppose if I write electron donating group and suppose if I write over here electron withdrawing group, let's say. Now, over here what I am doing is, I am taking over here a reactivity order for ARSE reaction. Now, what is the concept? Which groups enhance the reactivity of a benzene? Yes, the answer is correct. A donating group increases the reactivity, whereas a withdrawing group decreases the reactivity. Now, what is donating and what is withdrawing group? I think so you all should know now, up till now, or if you don't know, please see. Donating groups are the one which shows positive effect like plus I, plus H, even plus R is also possible. Whereas electron withdrawing groups are the one which are showing negative effect, minus I, minus H and minus R. So, now my question to you is, let's come to our question. Now, kids, before we start anything, similar type of a question also was there in a past NEET paper. Now, what is the concept you have got over here? Just see. I have got over here a cyclic ring which is a benzene molecule. You can see very clearly. Now, I have got over here as NH group. I have got over here a carbonyl group and I have got over here again another benzene ring. Now, my question to you is, let's label both the benzene rings as A and B. So, now over here there are 2 rings on which your substitution can take place. But now question comes is, do substitution will take place on both the rings? No. Substitution will take place on only any one ring, either the one which is on the left hand side A or either on the ring B. Now, the question is, benzene is attached to an atom I think so we know this as a key atom, it contains a lone pair. And whenever if you have got a key atom containing a lone pair electron, it will start showing electron donating effect. Whereas for a ring B, the group or an atom which is directly attached to benzene is a carbon, and which is attached to an electronegative atom, this group is acting as an electron withdrawing group. So now you tell me which group? Yes, like suppose in this case of nitration, I think so nitronium ion, which is an electrophile, will attack. Now this electrophile will attack on which ring? Either ring A or B. I think so the answer is ring A. That means this nitro group will go and attack to electron donating group. And even one more thing, in electron donating group also, child, you should know the product always obtained would be ortho and para, where para will be major whereas ortho will be minor. So in this case, I think so according to this position is para position. So your attack will take place over here. And hence as for the situation, your nitro group should get attached to a left hand side of the ring. I think so here you can't see that. So this is incorrect. Here also you can see the attachment of a nitro substitution is not at ring A. So this is also not possible. In this case, child, it's correct where you can see it's a para position. So your correct answer in this case is B. Is the term clear? Fine. I hope so it is clear to you. Let's proceed with the next topic what we have, or next MCQ, child. Now here, child, they have given one question which is very simple based on basicity. Now what they have given, which of the following is the strongest base? Now before we start this point, child, if you remember, I had told you one concept, that is whenever if you have got an R attached to NH2, whenever if you have got an H attached to NH2, let's take an ammonia also for comparison. And lastly, child, we have got an aromatic ring where you have got a nitrogen attached to a benzene. Now the question is, out of these three compounds, if I want to check which one is more basic in nature. So I have told you, child, remember one thing, we have to check something called as a resonance. Whenever a lone pair of electron gets involved in resonance, its basicity will decrease. Yes. So out of this three examples, the least basic will be nothing but an aromatic amine. Now out of primary amine, or you can call it as amine, aliphatic amine and ammonia, the differentiating part is H and R. H generally don't show any effect, but whereas R shows plus I effect or electron donating effect. And I think so basicity increases due to donating groups. Hence, this should be the answer. So what I have given you a generalization, if you remember, child, the generalization given to you is aliphatic amines are more basic than ammonia. Ammonia are more basic than aromatic amines. And this order what I have given is basicity. I think so you hope so this is clear with you. Now let's start, take the question. Now they are asking which is the strongest base. First of all, if you see the example number B, is nitrogen directly attached to a benzene? Yes, it is an aromatic amine, correct? Now if you see in this example C, again you can see over here, your nitrogen is directly attached to a benzene. It's again nothing but an aromatic over here. There is one small printing mistake, child. It should be 2 over here. Now again in the D example, if you see, again it's an aromatic amine. Again resonance is involved. Again this is aromatic, so basicity is less. So out of this 4 example, if you see, B, C and D are aromatic, whereas your A is an aliphatic amine. And I think so I have already mentioned, out of aliphatic and aromatic, whose basicity is maximum? It's aliphatic. So over here, your correct answer for this particular MCQ is A. Hope so this child is clear. Yeah. Let's proceed with the next question, child. What we have over here, child. Now this is the question where you have got statement 1 and statement 2, and we'll see what it is. Now first point, aniline does not undergo Friedel-Crafts reaction? Yes, child. I think so. One of the very common reaction of a benzene is Friedel-Crafts reaction, and you should know when you study Friedel-Crafts, there are some limitations like aniline and phenol do not show Friedel-Crafts reaction, and I think so according to that the statement 1 is correct. Now let's see the second statement. Friedel-Crafts reaction is an electrophilic substitution reaction. I think so this statement is also correct, child. If you remember, Friedel-Crafts reaction is generally shown by benzene, and benzene shows generally electrophilic substitution reaction. That means your Friedel-Crafts reaction is also an example of electrophilic substitution reaction. So both the statements are correct. So here the correct answer is both statement 1 and 2 are true. That is the correct. So correct answer for this MCQ is A. Kids, so let's proceed with the next question what we have. Now over here, child, the question given to you is the best method to form aromatic iodides. Now basically, child, if you see out of this 4 example, the most probable answer what you can see is related to diazonium salt, and this is one of the very common reaction, child. If you remember, they have given as AR, but I will write it over here a benzene ring so that you get a clarity. Over here I have got a benzene, and to it I have got N2 plus, and nothing is mentioned, it's okay. It's a diazonium cation given. Now when it has been treated with Ki, what happens? You have got what? Normally whenever you take a benzene salt, it will be in a form of salt. Let's take a benzene diazonium chloride. What will happen? Your N2 gas is lost. First, your Cl minus and K plus will get lost as KCl. So your byproduct obtained are N2 gas. You have got another byproduct KCl, and what is left out? This iodine will go and attack to a benzene. Will I get nothing but the answer as iodobenzene? And I think so this is one of the good method to prepare iodobenzene. Is that term clear, child? Hope so this question is clear to you. So correct answer for our MCQ is nothing but option C. Yeah. Let's proceed with the next question, child. What we have on the screen? Again, this is statement 1 and statement 2. Let's see what we have. First statement says that nitration of aniline can be done conveniently by protecting amino group through acetylation. And I think so, yes, this step is correct, because see, when you talk about aniline unit, now whenever you have got an aniline, what is basically aniline? It's a benzene ring containing NH2. Now, when this particular compound is treated with any acetylating agent, now acetylating agent, there are 2 acetylating agents. One is acetyl chloride and other one is nothing but acetic anhydride. So I'll just take over here acetyl chloride. Now this is acetyl chloride. Now I think so, child, you should know this. Okay, over here, this is nothing but my leaving group, and from here your active H, which is attached to nitrogen, will get lost. Your byproduct would be HCl. What will be the product form? I think so the product form would be a benzene ring containing NH, and now you will have your acetyl part attached to it, and this compound is, I think so, known as acetanilide. Now let's see what they want to say. Now statement number 1 is telling that when you do a nitration of aniline, what happens? Generally when you do a nitration of aniline, yes, when you do nitration of aniline, generally what happens in case of nitration, you get 3 products. One is you get ortho product, other one you get is a para product, and one more product is obtained unexpectedly, which is meta product. Now the question is, suppose if I want to remove or I don't want my meta product to be formed, then I need to do some modification, and hence what we do is we carry out not a nitration directly on aniline, we first carry out acetylation which will protect my amino group, and hence I think so this step, what you can see, a statement number 1 is a correct statement. Now let us have a second statement. Statement number 2 says that acetylation of aniline results in increase in electron density in a benzene ring. Now basically what do you mean by that? Now acetylation of aniline, that is the reason why I have written the reaction. Now once the acetylation is done, will your electron density on a benzene ring will increase? Let's check. Over here you have got nitrogen containing a lone pair. Now you don't have anything else, so this lone pair will get involved in resonance. So it is increasing the electron density on benzene. But after getting acetylated, this lone pair will give its electron pair to a benzene, which will increase, but at the same time even this lone pair has to satisfy into a resonance with this carbonyl group also. So because of that, what happens over here, this lone pair has to do 2 resonance stabilization, one to a carbonyl and one to a benzene, and due to which what will happen, the efforts or the resonance towards benzene ring will decrease. That means over here the statement number 2 says that acetylation of aniline results in decrease should be the statement, but they have given increase, that means this statement is incorrect. So you have your statement number 1 correct and your statement number 2 incorrect. So here both the statement, no, that cannot be the case. Statement 1 is true, but statement 2 is false. So your correct answer has to be C. Is it done? Hope so this is clear, child. Let's proceed with the next question what we have. Now child, over here what we have, which of the following will be the most stable diazonium salt? Now basically child, we go ahead, I should try to remind you one thing, whenever you write and aryl diazonium salt, now please listen child, when you write a diazonium salt, we write a diazonium salt like this, where you have got N, triple bond N, this is plus. Now I think so you should know one thing child, we have studied in the syllabus aryl diazonium salt and alkyl diazonium salt. Aryl diazonium salts are stable as compared to alkyl, and the reason for that is what? It's nothing but a resonance involved. Is the term clear? So now if you check in this case, your option B is alkyl diazonium salt, which is comparatively less stable. This is ethyl diazonium salt, again it is less stable. Here also you can see it's an alkyl diazonium salt which is less stable. Whereas only, I think so you should know, aryl diazonium salts are stable. That means our correct option is A, because of resonance stabilization. Is the term clear? Sure. Let's proceed with the next question what we have on the screen, child. Yeah, that is the number of chiral carbon atom in beta D glucopyranose or beta D glucose. Now basically child, we have already done, whenever you have got a term called as glucose, generally glucose contains how many chiral center? It contains 4 chiral centers, correct? It's a 4 chiral centers, yeah, carbon. But when glucose forms a ring, that is when it is forming a cyclic ring, let's say the example given to us is beta D glucose, then what happens? Your number of chiral center increases by 1, so it contains 5 chiral carbon. So the question asked is, have they asked only glucose or have they asked beta glucose? they have asked beta glucose. So, the number of calorie center in this case has to be 5. So, the correct option what we have is 5. Let us begin with the next question, child, what we have on the screen. Now, child, over here what they have given. Question number 13 is like this: which statement about ribose is incorrect? Now, basically what do you know about ribose, child? Ribose is nothing but monosaccharide. Point number 1, it is a monosaccharide. Point number 2, it contains aldehyde group. So, we basically call it as an aldose sugar. Then, we know that it contains many OH groups. So, can I call it a polyhydroxy compounds? And the most important, it contains only 5 carbon atom. So, can it be called as pentose sugar? So, now let us understand the question. Now, they have given us which statement about ribose is incorrect. Now, ribose is polyhydroxy compound. I think so, it is a correct. So, it cannot be the answer. Ribose sugar contains aldehyde. Yes, I think so, this is correct. But as per our option, this cannot be the answer. Acha. Carbohydrates are definition wise only polyoptically active compounds. They are optically active. So, this cannot be the answer. Only one answer which I think so, C is nothing but option C is the correct answer, because ribose sugar contains 5 carbon and not 6. So, this is an incorrect statement. So, correct option for this example or this MCQ is C. So, hope so, child. I think so, up till now what has been discussed is clear. Yeah. Let us proceed with the next question what we have on the screen. Child, MCQ number 14. Now, when you talk about DNA and RNA, yes, first of all, DNA and RNA consist of what? Whenever you say it is a DNA or RNA, basically we call this unit only as nucleic acid, correct? Now, basically nucleic acid is made up of only 3 units. First, it is the sugar. Second, it is a phosphoric acid. And third unit, it is a nitrogen containing bases, correct? Now, what has been mentioned? DNA and RNA are chiral molecule due to presence of what? Now, when you talk about chiral, in nucleic acid, I think so it is made up of 3 things. Phosphoric acid is not chiral in nature. Even the nitrogen bases what we have with us, they are also not chiral. So, what is that part which makes this nucleic acid chiral is the sugar unit, and the sugar unit is because carbohydrates, which is sugars, are optically active and hence they are chiral in nature. So, the option what we have is what? We can see chiral basis cannot be the answer. Even a phosphate ester linkage is also not the answer. Only the correct answer is 2, where you can see D sugar and L sugar. Now, one more important information, child, you should know, in nucleic acid, the sugar what we have is always a D sugar, not an L sugar. So, even this option is also incorrect. So, the correct option for our MCQ is C. Hope so this is clear, child. Let us proceed with the next question, child, what we have. Now, again the next question what we have is assertion and reasoning. Over here there are 2 statements given to you. Maltose is a reducing sugar. Yes, maltose is a reducing sugar, we know that. Which gives 2 molecules of glucose. And I think so, yes, maltose is nothing but glucose plus glucose and it is a reducing sugar. That means your statement of 1 is correct. Now, let us see the statement number 2. Now, statement number 2 says that your maltose has got 1,4 beta glycosidic linkage. Now, you should know one thing, child. when you talk about the maltose, now maltose is nothing but a combination of D-glucopyranose and another unit is also nothing but D-glucopyranose. That means you have got a glucose unit only which is 6 membered. Now, in maltose, you have got both the units alpha and hence both are connected by an glycosidic linkage. And which carbon atoms are involved? First unit C1 is involved and second unit C4 is involved. That means your maltose is an example of 1,4 alpha glycosidic linkage and it's not beta linkage. That means as per our question, if you see your reason what you have got 1,4 beta is incorrect. That means your assertion is correct but your reasoning is not correct. So over here you can see both assertion and reasons are correct but R is not a correct explanation. That cannot be because both the statements are not correct. Over here you can see A is correct but R, that is reasoning, is not correct. Yes, so I think so the most appropriate option is your option B because statement 1, that is assertion, is correct and your option reason number 2, that is reason, is incorrect. So we are the correct option for this MCQ is B. Let's proceed with the next question, child. What we have now here, child, this is one of the very common concept. Again assertion, reasoning. I think so what they have mentioned over here, you have got nothing but a sucrose solution. Now when you talk about sucrose, basically sucrose, yes, is dextrorotatory. It's a dextrorotatory. So what has been mentioned? A solution of sucrose in water is a dextrorotatory. Obviously when you will take a table sugar, what we intake, child, it's a sucrose. As it goes in a water and dissociate, it is an dextrose sugar which will rotate the plane of plane polarized light to a right hand side. Yes, but on hydrolysis, gives you what? It gives you nothing but glucose unit and fructose unit. Is it clear? And that is also equal amount. It gives you equal quantity of glucose and fructose. Now what happens? Now see, if you see your textbook, they have given some data and that data is, in case of sucrose, the optical rotation value is 66.5 degree. Yes, whereas glucose has got a rotation value is 52.5 degree, which is dextro, and for a fructose the value is minus 92.4. Now when you check, yes, the beginning sucrose, it's a dextrorotatory, correct? But when it gets hydrolyzed, it is a mixture, and whenever you have got a mixture, it's the resultant, what is the output. Now out of these two value, which one is a bigger or larger value? The bigger value or larger value is 92.4 because plus and minus just only indicates the optical rotation. That means over here, initially the substance is dextro, means when it is sucrose, after hydrolysis it becomes lavo. That means what do you see that sucrose after getting hydrolyzed changes its rotation, optical rotation is changed, hence we call sucrose as invert sugar or we call this process as inversion. So now when you see the statement, a solution of sucrose in water is dextro, but on hydrolysis in presence of little amount of HCl, obviously for hydrolysis you require some amount of acid, it becomes lavo. I think so, yes, the statement is correct. Now second statement, sucrose on hydrolysis gives unequal amount of glucose and fructose. I think so this cannot be the case, because sucrose always on hydrolysis gives equal amount of glucose and fructose. So the statement number 2 what you can see over here is incorrect. So again the statement same. I think so the option what you have got is A is correct, but R is not correct. So your correct option is B, child. Is it done? Sure. Now let's proceed with the next question, child. What we have now, when you see, I think so question number 17, statement 1, amino acid exists as internal salt called as zwitterion. Correct? Now child, if you remember alpha amino acid. Now what is alpha amino acid? Basically a structure of alpha amino acid is like this, where we generally represent alpha amino acid like this. Correct? Now you have got NH2 and this is that alpha position. Correct? Now I think so you are aware that your COOH group is an acid. Your NH2 group what you can see is a basic or a base. Is it term clear? Now you tell me one thing, what are acids? Acids are nothing but proton donor, and what are bases? Proton acceptor. So can't you see over here in this case, your acid will lose out your H and your amino group will take that H. Will it? Nothing but give you what? R, CH, COO minus, and here you will get NH3 plus. Now question to you, child, is whenever acid, yes, loses its H plus ion, does it form a negatively charged part conjugate base? Whereas a base when accepts a proton, it will be positively charged conjugate acid. I think so here it look like as a salt, and I think so this particular dipolar ion, now why it is called as dipolar? Because there are two poles created or two charge created, it's a dipolar ion. I think so we call this only as zwitterion. So now let's see the statement, child. Statement 1 says that amino acid exists as internal salt called zwitterion. Yes, this statement is correct, because any substance who contains acid as well as base within the molecule, it will be always existing in a zwitterion form. Next, the H plus ion given by the acid is captured by amino group having a lone pair. I think so that's the reason I have shown over here. So even this statement is also correct. So over here both the statement 1 and statement 2 are true. I think so both the statements are correct. Hope so this example is clear. Let's see the next situation what we have. Now here, child, you can see very clearly which one of the following set of monosaccharide forms sucrose. Now basically, child, I have told you sucrose, yes, is a disaccharide. It's a disaccharide, and these disaccharides on hydrolysis will give you what? On hydrolysis it will give you what? It will give you glucose plus fructose. That means your sucrose is made up of these two units only. Correct? So now as per the situation over here, I think so they have given galactose, yes, and glucose. This cannot be the answer. Now I think so the next important part is what? The next important part is what? The glucose what we use is nothing but alpha D glucose, whereas the fructose what we have got present in sucrose is beta D fructose. Correct? Not only this, child, one more important point. Even you should know that your glucose is in a 6-membered ring form, which is called as pyranose form, and fructose what you have got is in a 5-membered ring, which is furanose form. And lastly, I think so what will happen? Both of them will get connected by an oxygen linkage, and the carbon which are involved is C1 of glucose and C2 of fructose. That means if you see, you have got alpha and beta. Now here's, child, Glucose beta is not there because we have got alpha glucose. So, this is incorrect. Now, its B is given as alpha D, 6 member is correct, but over here beta D fructose 6 member is not correct. So, even this is incorrect. So, your correct option I think so in this case is the last option D. I think so in the lecture also we have discussed this part and I have told you to remember this. Correct child? I think so this is clear. Let us proceed with the next question what we have. Now, I think so this is a very straightforward question child, it is an information based. The non-essential amino acid among the following is, and I think so the correct answer is alanine. Now, some of you must be thinking, sir, how you came to know? If you remember child in the classroom, I have given you one mnemonic to be remembered. It is a private, Tim, Hall, H, A, L and L. Now, these are those 10 alpha amino acids which are essential alpha amino acids and the remaining ones are called as non-essential. Now, you must be thinking, sir, what these are? If you see in the lecture I had discussed, P is nothing but phenylalanine, V is valine, T is nothing but tryptophan. Then you have got the next T, in this case you have got I, you have got M and all these things I have already mentioned. So, here the most appropriate answer what you have got is nothing but an aniline. Is it correct? Fine. Hope so this question is not that difficult, only the thing is you need to read your textbook properly, correct? Let us proceed with the next question what we have. Now, over here child, this is a question which is very simple based on IUPAC. Now, here I think so you can see this is an amide linkage and according to IUPAC you have to select the long chain which should include functional group carbon. I think so over here this can be a number 1 carbon, this can be number 2 carbon, this can be number 3 and this can be number 4. So, there are 4 carbon atom amide. So, now 4 carbon atom if you see it's 3, it cannot be the answer. Again it is not the case, only the answer what you have got is correct. So, over here the correct answer for our MCQ is B. Is it term clear child? Let us proceed with the next question child. Now, the question what you have got is what? Give IUPAC name of this compound. Now, when you start with this compound, is this compound over here a cyclohexane? Yes. And I think so you can see options are very clear. It is not a benzene related compound. So, this option is cut. I think so this is benzene related name given to you. This option is also cut. And I think so here also you have got benzaldehyde related, benzene related, this option is also cut. But still if you want to know how this compound has been named, I will tell you. See, we have got over here a cyclohexane ring where you have got an acid and you have got an aldehyde group, correct? Now, as per the situation, can I call this becomes your parent chain and the name of this compound becomes cyclohexane. Now, out of these two, who is a primary or a priority functional group? I think so the main principal functional group is a carboxylic acid. And what is the suffix name of carboxylic acid? It's an oic. But you remember when you use the word oic? When your functional group carbon is a part of a chain. Here your functional group carbon is not the part of the chain. So here we use the word as carboxylic acid. And lastly, you have got some side chain and that side chain is at 4th position. And what is that group called as? It's an aldehyde. And what is the name of an aldehyde? In the prefix, it's a formyl. So we have got a name called as formyl. And what is the position formyl? It's a 4th position. So your correct answer for this MCQ is option C. Is it done, child? Hope so this is simple, not that difficult. Let's try with the next question, child, what we have. Yeah, this is a very good question, child. What is the correct IUPAC name of the following compound? Now here if you check, you have got over here multiple groups, but you should know one thing very clearly. Aldehyde is taken over here as a preference. So this compound can be called as benzaldehyde. Yes. So we have got over here a benzaldehyde. We have got over here a benzaldehyde. That means these two options are not possible. Now, when you start numbering this, the next question comes is, sir, what would be your number 2? Because there are two groups, bromo and hydroxy. Now listen child, once the principal group is decided, remaining all groups will be now a side chain. Then you have to go for alphabetically who comes first should get the lowest number. So here, what is the concept? If I go on the side, I get 1, this is 1, so this will become 2. If I go on this side also it becomes 2. So bromo and hydroxy, when you compare, bromo comes alphabetically first, so your correct numbering system will be like this child, where you have got bromine second position and hydroxy at 6th position. So your correct answer in this case is D and not A. I hope so this is clear child. Fine. So let's see the next question what we have. I think so this question is again a very simple one. Relation between the above compounds shown. Now basically when you see this compound child, are these compound position isomer or chain isomer or identical or functional? Do one thing, find out the IUPAC name of this. Now let's try the first compound. The first compound what you have got over here is something of this type, and the second compound what you have got is this, which you can see very clearly, where this is the bond and they have shown over here. Now let's start naming them. Yeah, suppose if I start, I have got double bond. So always whenever your chain has to be selected such that your double bond should get the lowest number. So can I have, this is carbon number 1, 2, 3, 4 and 5. So now how to name this? I think so we have got over here a cyclo group. Hex is given also as one of the case. Since there is a double bond, so it will be cyclohexene. And what is the position? Yes, there are two methyl groups. So can it be called as a dimethyl? And what are the positions of two methyl groups which are? Here you can see it's 3 and here it's 5. So it's a 3, 5 dimethyl. Now let's try this last example. Here. Again in this case you can see a double bond is there. So priority has to be given to a double bond. So here it's 1. Here it becomes second, here it becomes third, here it becomes 4, here it becomes 5. So this compound is again, if you see, cyclohexene, yes, and not only this, it has got two methyl groups. So it's a dimethyl and position is 3, 5. So if you notice over here, both the names are same. That means over here these are not two different compounds, they are one and the same compound. So your correct answer is C. Hope so this is clear child. Fine. Let's proceed with the next question what we have got on the screen. Now if you see the next question is, which of the following does not show geometrical isomerism? Now before you start with the geometrical isomerism, I think so you should note two conditions. The first condition is what? That restricted rotation across the bond should be there, which I think so it's possible for all. Main important is the second condition. What was the second condition child if you remember? Suppose if I have got an alkene, now you have got two groups over here and two groups over here, up and down. Suppose if I have got a group A and B, and let's say you have got a group X and Y. The condition is if A is not equal to B and X is not equal to Y, then only geometrical isomerism is possible. So now let's take an example child what we have. So our first example if you check child is nothing but what? The first one, pent-1ene. Now I think so when you draw a pent-1ene in a bond line, you have got over here a double bond, yes, 1, and for that first position only you have got one Cl, and on second position you have got one Cl. So now if you see, this compound has got one H and one Cl. Here also you have got one Cl and one H. This compound will show geometrical isomerism. Second example, Now you have got second example is 1,3 dichloropentoene. So first of all, can I write a pentoene something like this? Now on first position and on third position, you have got dichloro. Now my question to you is, do this particular carbon atom contains two different groups? Yes. In this carbon atom also, child, it contains one this group and one H. So they are different. So even this will show geometrical isomerism. Yeah. Let's take the next example. See, 1,1 dichloropentoene. Now pentoene, when you draw, I think so this is one ene, and first position only you have got two Cl groups. So here you have got one Cl and here you have got another Cl. Now if you check, child, in this example, doubly bonded carbon, both the groups are same, and if they are same, this compound will not show geometrical isomerism. And I think so, as per the option what we have, or question, if you see which of the following does not show geometrical isomerism, the correct answer for this is nothing but C. I hope this question is very clear. Same way you can even try a fourth example. You will see that this molecule shows geometrical isomerism. Is the term clear? I think so this is clear. We will move ahead to the next question. Now the question given to you is, which of the following compound is optically active? Now if you check this question, which compound is optically active, so I will put it over here in front of you right now, this question, just check. Now when you talk about optically active, that means basically this compound would have a situation called as chiral carbon. So here if you check, normally I have told you that CH3 group, CH2 groups, you do not have to check. So the carbon to be checked is this one, and I think so it contains four groups, OH, CH3, ethyl, NH. This is a chiral carbon, so it will be optically active. Now when you come to this example, child, if you check this carbon atom, yes, you have got one H, one CH3. Now as you come on this side, you have got double bond, and as you come on this side, you have got saturated carbon. I think so you have got all four different groups over here also. This is chiral, so it will show optical activity. Now when you come to this carbon atom, child, yes, so here you can see this does not contain chiral center because you have got both the groups same. Yes, not only this, even you can check this also. Now this carbon atom, if you see, two Cl groups are different, but now when you see the other groups and you see the other groups, are these groups same? And if these groups are same, this compound would be having no chiral center, and since no chiral center, this compound would be optically inactive. Now same way you can even check this also. If you check this, it has got one H, so these are two different groups. Now when you come over here and when you come over here, you can see on the third carbon atom you have got double bond, and on the third carbon atom on the other side you have got saturated carbon. So here also you have got a chiral carbons. Now as per our question, if you see, option A, option B and option C contains chiral carbon, so they will be optically active, whereas the question asked to us is optically inactive. So which is the correct answer? Your option C is the correct answer. Is the term clear? So student, let's proceed with the next question what we have. Now over here, the question asked is, in which of the following species incorrect direction of inductive effect is shown? Now basically when you talk about inductive effect, child, suppose if you have got a carbon attached to chlorine, correct, and I have got over here some groups, let's say I have not mentioned but I have shown valency. Now out of carbon, because see, carbon has given one electron and chlorine has given one electron, so they have got sharing of electrons. But after sharing, what you will observe that the electron cloud is not equally spread, since you know chlorine is more electronegative, hence it will start attracting electron, and because of this your carbon will get delta positive. And I think so this effect is only called as inductive effect. Is the term clear? Sure. And which is observed along sigma bond. Next important point is always the direction of the arrow is from less electronegative atom to more electronegative atom. Now in this case, child, the direction arrow shown is proper because this carbon atom is sp3 and benzene carbon is sp2, and I think so we know that sp2 carbon is more electronegative. So here your representation is correct. In this case also, child, if you see your carbonyl group present to an acid is sp2 and this carbon atom what you have got of ring is sp3. So here also direction is correct. Now in this example, being a negatively charged group, now negatively charged group shows which effect? Plus I, which will be showing a proper donating effect. Yes, and that's why even this is correct. But now in this example, if you check, child, carbonyl group, basically when you see, yes, carbonyl group, the example which I have mentioned is this, you can see very clearly the same example, which is example number D. Example number D. Now we know that this group contains a carbon which is sp2. Here you have got sp3 carbon. Here also you have got sp3 carbon. Which one is more electronegative, child? The electronegative atom is sp2. So the direction should be towards which side? Towards your carbonyl carbon. So direction should be towards carbonyl. Here I think so the representation given is incorrect. So correct option for this question has to be D. Is it clear? Hope so this is clear, child. Let's proceed with the next question, child, what we have. Now over here they have given a carboxylic acid, that is benzoic acid, and it is attached with one group called as X, and what they are asking, pKa value of the compound decreases if X is. Now basically what is pKa? Now see, this question is related to acidic strength. So we have already discussed one thing, that acidic strength is inversely proportional to pKa. That means if they are asking decreasing value, or you can see in which case your pKa value decreases, that means in terms of acidic strength it should increase. Yes. Now which are the groups which increases the acidic strength? Which are the groups which increases acidic strength? So if you remember, child, yes, in the lecture also we have discussed, here there are two types of group. One is electron withdrawing group and other one is electron donating group. Now here I have taken acidic strength, correct? Now generally when you talk about withdrawing group, all the groups which shows minus effect, that is minus I, minus H, minus R, they are withdrawing groups. All the groups which are positive effect showing groups like plus I, plus H and plus R, they are called as donating group. Now which group has a tendency to increase the acidic strength? Obviously the answer is electron withdrawing group increases the acidic strength and donating group decreases the acidic strength. So they are asking that among the following which group, yes, when attached to benzene will be increasing acidic strength. So now child, you should understand, when a nitro group is attached to a benzene, it will show minus R effect. When amino group is attached to benzene, you know it contains a lone pair on the key atom, it will show plus R effect. Over here also, child, the oxygen which is a key atom attached to a benzene, it will also show plus R effect. Over here also in methoxy group, if you see the key atom, what you have got is oxygen, again it contains a lone pair. So it will be acting as a donating group, again it will be plus R when attached to benzene. Is it clear? Now, as per the situation, which group is the one which increases the acidic strength? The one which shows negative effect, that means this is going to increase the acidic strength. This is going to decrease the acidic strength. This is going to decrease the acidic strength. This is going to decrease the acidic strength. So the question is asked, the one which will increase the acidic strength means the one which will have decreasing pKa value, and the correct answer for this can be A. Is it done? Hope so this answer is clear, child. Let's proceed to the next question what we have. Now over here, child, they have shown one molecule to you, and if you see that molecule is of this type, I think so you have got a cyclic compound having a ketone, having a ketone, having over here one H, having over here one CH3, correct? Now, what are they asking? Let's see, over here this position is called as P, this position is called as Q, this position what they have called as R, and this position what they have called as S. Now, question is, when this compound is mixed with NaOH solution, acid-base reaction occurs and snatches from organic, which carbon will lose easily. Now, simple hai, when you talk about acid base, first of all, you should know NaOH is a base. That means they want from this compound, which one is most acidic. Now, I think so, in the previous slide only we have told the group, yes, which are electron withdrawing group will increase the acidic strength. And I think so in this particular example, this group, what you can see is electron withdrawing group. Even this group is also electron withdrawing group. So here, this carbon, I think so child, which is nothing but P, yes, is attached to electron withdrawing group. Let's understand by one more way. Now, we all know child that whenever acid loses an H plus ion, does it form a conjugate base? Yes. So, let's start writing the structure of a conjugate base. I think so this is the case. Here you have got double bond O, here you have got double bond O, and you have got over here CH3 with H. And now what I have taken child, I have removed an H plus ion from position P. So, will I get a negatively charged ion called as conjugate base? Now, is this conjugate base resonance stabilized? Yes. And if it is resonance stabilized, that means it is more stable conjugate base. And we know that strong acids gives always more stronger base. So, as per this discussion, yes, your position P carbon atom H will be having more acidic nature. So, your correct answer has to be P. Is it clear, child? Hope so this is clear. Let's proceed with the next part. Your next question what you can have on the screen is this. Now, child, question number 29, and this question is very simple. Resonance is not possible in, and I think so this is a very simple question based on condition. Now, if you check child, your question number or option B, you have got oxygen containing a lone pair. Now, when a lone pair and a positive charge are on just an atom, can I call it's a case of a back bonding? Yes, so here resonance is possible. Now, if you check over here, there is a lone pair present on Cl. Is this lone pair and a double bond are in conjugation? Yes, so here resonance is possible. Now, when you talk about here, it's a sulfur. Yes, and here it's a negative charge. Now, again, whenever you have got a negative charge, yes, sulfur would be having a vacant d orbital, and hence again over here your delocalization is possible. So, if you check in option B, C and D, in all these three cases, your resonance is possible, but they have asked in which case it is not possible. I think so, you don't have anything conjugation over here, so your correct answer is A. So, let's proceed with the next question, child, what you have got on the screen. And the next question is based on most stable free radical. Now, basically, bacha, when you talk about stability of intermediate, you need to check the effects, and always the priority effect which you need to first check is resonance, then hyperconjugation, and then inductive effect. Now, in this our example, you can clearly make it out very easily that over here there is a free radical, but there is no resonance involved. So, here you can explain this with hyperconjugation. Here also you can't see any conjugation, so this also can be explained by hyperconjugation. Here you can explain it based on resonance plus hyperconjugation, and here you can see again it is based on only hyper. I think so out of this it is a very clear that wherever there is a resonance involved, it brings about a stability in the molecule or in the ion or in the radical. I think so the question asked is most stable free radical. I think so the most stable free radical is over here. Is it term clear? So I think so this should not be a difficult question for you. Let's proceed with the next question, child. What we have on the screen? Now the next question what we have is question over here. You can see which one of the following has inductive effect, mesomeric effect and hyperconjugation. Now child, before we start anything, for inductive effect what is our important requirement? It is nothing but difference in electronegativity is must. That means if you have got any functional group, basically it can show minus I effect. I think so in our compound you can see very clearly a functional group. That means this particular compound can show inductive effect, point number 1. Now second, if you check resonance. Now for a condition for a resonance is nothing but one of the conditions, pi bond alternate to a pi bond can show resonance. I think so, yes. So here you can see this pi bond alternate to this pi bond. So even a resonance is possible in this case. Yes, which is called as mesomeric effect. And what is the third situation? Hyperconjugation. Basically, which compound shows hyperconjugation? I think so. Hyperconjugation is shown by, yes, C plus. Second is C dot. And third one is nothing but alkenes. So these three compounds basically can show hyperconjugation well. Yes. And condition number 2 is presence of alpha hydrogen is must, which should be attached to sp3 carbon. Is a term clear? So as per this situation, alkene, the next carbon atom is alpha and it has got 3 alpha H. That means here you can see all the effects possible. Now that means your correct answer is this, but at the same time now let's discuss other options. Now in this case you can see only electronegative atom, that means it shows only and only inductive effect. In this example if you check there is a functional group, yes, so it will show inductive effect. And if you see this is alpha H and condition is matching to hyperconjugation. So here both the effects are there. In the third example I have shown all 3 effects. Last example you can see there is a functional group and attached to a functional group, and when both the functional groups are same, I think so difference in electronegativity won't be there. So no inductive effect. Next, you can see very clearly resonance because double bond alternate to double bond. Is it clear? And one more, some of the kids may be thinking even hyperconjugation, double bond, the next carbon atom to a double bond is alpha, but you can't take this alpha H because this alpha H is of sp2, whereas in hyperconjugation you require for sp3. That means the correct answer for this MCQ where all 3 effects should be observed is option C. Correct? Hope so it is clear. Let's proceed to the next question, child. Now over here child, the question given to you is arrange the following compounds in increasing order of the acidic strength. Now basically child, if you remember, I have told you already about the acidic strength. Yes, and what is that acidic strength? See over here. There are 2 types of groups, electron withdrawing group and electron donating group. Now the group, yes, I have written over here acidic strength. Now which are the groups which are electron withdrawing? The one which shows negative effect. So minus I, minus H and minus R. Whereas in this case it's a plus I, plus H and plus R. So now which groups are the one which increases the acidic strength? The answer is electron withdrawing group increases and donating group decreases the acidic strength. Now let's do the discussion. Now before we start anything, first of all just check, do acidic groups are same? See here it is same, here it is same, here it is same, but here it is different. That means this is a phenol and these all 3 are carboxylic acid. Now when you talk about carboxylic acid and phenol, I think so carboxylic acids are more acidic whereas phenol is least acidic. So in this case the least one, yes, will be the fourth one, which is phenol. Now they have told you to write in increasing order, so I have kept the fourth one. Now the fight is between first three. Now let's see the variation. The first variation, you don't have any group over here, so this is something called as dash, which I call it as you don't have any effect of additional group. Here you have got a methyl group attached to benzene. When methyl group is attached to benzene, we have got plus H effect. When a Cl is attached to benzene, we know it shows plus R effect and minus I. But since halogens are exception where minus I effect is dominating. Now you tell me, out of this three, first, second and third, which group will increase the acidic strength? Obviously the one which shows negative effect. So this will increase. This will decrease. So ideally, who should be the one who should now come in the list? After 4, the minimum will be of this, which will be second. After that, I think so you should have first, and the one which will be the most acidic would be the third one. That means this is increasing order, which means it is from low to high, and that means as per our option what you can see is 4, 2, 1 and 3. So your correct answer is A. I hope this is clear, child, to you. Yes. Let's proceed with the next question, child. What we have on the screen? Yeah, the most stable carbocation. Now when you have a stability of carbocation, and one more thing, if you have got ring, whenever you have got a ring, first of all think little bit about aromaticity, and I think so this is one of the very common example we have done. Here this example, if you see, it is an cyclic but which contains 4 pi electron system. So this compound is anti-aromatic. Whereas this compound, if you see, contains a 6 pi electron, complete conjugation, cyclic, planar, everything. So this becomes an aromatic. Whereas both these examples, if you see, they come under non-aromatic. And now, bacha, basically before we start anything, you should know one basic idea or order, that aromatic is more stable than non-aromatic, and non-aromatics are more stable than anti-aromatic, and this is something called as what is stability order. It is which order? It's a stability order. So now based on that, I think so you can discuss very easily. What is that? I think so this only has to be the most stable carbocation, correct? Let's proceed with the next question then, child. Now here on the screen you can see very clearly, arrange the following carb anion in a decreasing order of the stability. Now again this question comes based on stability of C minus. Now bacha, before we start anything, let's discuss one small thing which we did in our lecture, that there are 2 types of groups. One is electron withdrawing group, other one is electron donating group. Now let's write about these groups first. Over here, withdrawing groups are those one which shows negative effect. It can be a minus I or minus H or minus R. Whereas in case of donating group, we have one which shows positive effect, plus I, plus H and plus R. Is it term clear? Now question comes is, sir, how you will relate these groups with stability? Now if you know, over here we have got carb anion. Now basically you tell me carb anion contains what? It contains a negative charge, means there are extra electrons, and whenever you have got extra electron, they will start repelling each other, or repulsion will increase, repulsion energy will increase, so stability will decrease. So in other terms, if there are some groups who has a tendency to decrease or to remove or to withdraw electron, then your repulsion will automatically get decreased and stability will increase. So, here I think so electron withdrawing group will increase the stability and electron donating group will decrease the stability of C minus. Now, just what we have to do is we have to find out the effects. Now, over here if nothing is there, that means over here you have got H and H has got no effect. Now, when you see methyl group is attached to benzene, it shows plus H effect. Now, when a nitro group is attached, it shows minus R effect. And when methoxy group is attached, I think so it contains a lone pair on a key atom, it shows plus R effect. Now, question comes as, which group is there who will increase the stability of carbon ion? I think so minus group will increase and plus groups will decreases. Is it term clear? So, the stability order of C minus should be like this. The one which is most stable is I think so the third one. Then I think so both of them are decreasing. So, you should have now first one should be the answer. Now, both the effects are the one to decrease. Resonance is more dominating as compared to hyperconjugation. So, here it will be a maximum decrease, here it will be minimum decrease. So, while in a decreasing order you should have 2 first and the last should be the fourth one. So, as per answer key what we have got 3, 1, 2, 4. So, our correct option for this question has to be D. I hope children this is clear to you. Let us move to the next question, child. Now, here child what we have? Assertion reasoning based question is given. Tert butyl carb anion. Now, see over here CH3, CH3 and CH3 and minus is to be compared with CH3 minus. Now, what they have given? When you talk about the stability, child, do over here your methyl group contains a donating character. Yes, and these are electron donating groups, and electron donating groups due to which effect? Due to plus I. Now, when they will start donating electrons, just think what will happen. The electron density will keep on increasing more and more and repulsion will take place more and more, and if the repulsion energy increases, so stability decreases. So, in other terms, electron donating group decreases the stability of C minus. So, here your CH3 minus will be more stable than tert butyl, and I think so they also have written tert butyl carbon ion is less stable than methyl carbon ion. Yes, so this statement is correct. Now, let us see the reason. The plus I effect of the methyl group tends to stabilize the tert butyl? No, because of this methyl group, child, your carb anion is getting destabilized, and if it is getting destabilized, that means the statement is wrong. That means your assertion is correct but reason is false. So, your correct answer has to be C. If the assertion is true but the reason is false. I think so this answer is clear to you, child. Let us proceed with the next question, child, what we have on the screen. Now, which of the following compound will form alkanes on reaction with Grignard reagent? Now, child, this is one of the very common questions which I had told you a long back, that whenever if you have got a Grignard reagent RMgX, and if it has been treated with if it has been treated with solvent or a compound which contains acidic edge, solvent or a compound which contains acidic edge, like water you have got with you, or alcohol if you have got. Is a term clear, child? Now, it can be even sometimes ammonia also. Even if you want, sometimes you can even see a terminal alkynes. Even you can see sometimes phenol. In all these cases, if you check, your solvent contains an acidic edge. 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 Now, we know that in a Grignard reagent, the R part attached to metal is nothing but a negative part. So, what will happen? This negative part will get joined to this positive part, and will I get nothing but the answer as R attached to H as an alkane. So, Grignard reagent can react with these acidic, or what we call it as polar protic solvent, to give you alkane. And I think so, out of these 4 examples, the polar protic solvent, what you can see is only one, which is nothing but alcohols. So, correct answer for this question is nothing but A. Correct? So, hope so this is clear. Let's proceed to the next question, child. Now, this question is one of the very common question, child. Which sodium salt will be heated with soda lime to obtain a propane? Now, what is this reaction, child? Let's see. Suppose if I have got a carboxylic acid in a form of a sodium salt, let's say, and when it has been treated with soda lime, that is nothing but NaOH, and calcium oxide and heated, what will happen? Yeah, this entire part will get lost out as a byproduct as Na2CO3, and what you will left out with, you will get R with one H. So, will I get an alkane formed? Yes. Not only this, suppose if your compound contains n number of carbon atom, the alkane obtained would have one carbon atom less. That means if they have asked which sodium salt when heated with soda lime will produce propane. Now, propane contains how many carbon atom, child? Total 3. Now, for 3, if the product has to 3, your starting material should have 4 carbon atom. That means in this case, your option A cannot be, because this part when it is get lost, you will get ethane as a molecule. So, this cannot be the answer. Now, if you check over here, if this gets removed out and you get H over here, can I have a propane obtained over here? Yes. So, your correct answer is B. Not only this, child, there is one more. Even you can see the D option, both B and C, so you have to even check the C option also. In this case, child, when this particular part is getting lost, yes, what will happen? This part will get H, and I think so this molecule is also nothing but what? CH3 twice CH, and that H will get one more H from this part. So, this molecule is also nothing but what? CH3, CH2 and CH3. Can I call even this will give you propane? And that's the reason. In this case, your correct answer is D, both B and C. Is it done, child? Yeah. Let's proceed with the next part, child. Over here, the next question what you have got, child, is the number of monochloro derivative of isohexane is, and the question asked is only structural isomer. Now, first of all, child, you should know what is isohexane. Now, when you see isohexane means what? Total number of carbon atom is 6, but out of that I need to make iso. So, one carbon atom will be a branch at second carbon atom, correct? Now, when I have written this particular example, child, you can check very clearly over here. Now, if I carry out a monochlorination, now basically for a monochlorination, you require a Cl2 in presence of light, correct? Now, what will happen? The first point, The first discussion is something like this, where you can see this is the first carbon where your chlorination can take place, which will be a primary carbon. This can be the second place where your substitution can take place, which can be a secondary carbon. This is the third place where it can again take place, which is again a secondary. Now, this is again the place where H can be substituted, and this can be a tertiary. Now, one last, out of these two, both are them same. Any one of the isomer you tell, it's again a primary. Since this molecule is not symmetrical, you can have all 5 possible products in this particular case. So, the exact answer for our question is nothing but which one? Yes, I think so. The correct answer is C. Is it clear, child? Sure. Since the question asked is structural, so we have only found out the structural isomer. We have not talked anything about stereo, correct? Now, let's proceed with the next question, child. What we have on the screen? When 1, 1, 2, 2 tetrabromopropane is heated with zinc powder in alcohol, which is formed. Now, I think so. This is one of the very common example, child. If I have got total, let's say 3 carbon atom, and I have got one over here as Br, one as a Br over here. On a second position also I have got a Br, and over here also a Br over here. And I will put required number of hydrogen as CH3 and CH. Now, what they have told, treat this with zinc, yes, in alcoholic condition. Now, what happens? I think so, you know that zinc has an ability to remove both these bromines with zinc, and even both these bromines with zinc. That means you need to balance this. Your byproduct obtained would be zinc bromide, 2 moles. And what will happen? Here you can see first 1 mole of bromine is lost. Here your second mole of bromine is lost. That means, can I call it a dehalogenation? And since 2 times elimination are taking place, so you will have got formation of 2 pi bonds, and hence in this case you can have your answer, which is nothing but propyne. So the correct answer for this example would be, option A. Hope so this is clear. Let's proceed with the next question, child. What we have now, anti-Markovnikov addition rule of HBr is not observed. Now, basically when you talk about Markovnikov and anti-Markovnikov, you must be knowing it one point which I had mentioned. Markovnikov and anti-Markovnikov rule works only and only if your alkene is unsymmetrical. That means for a symmetrical alkenes, you don't require any rules, correct? So, if you see out of 4 example, here you can see very clearly but2ene, that means you have got a double bond exactly in the middle, and hence this becomes your symmetrical alkene, and symmetrical alkene basically do not show Markovnikov as well as anti-Markovnikov rule. So, I think so the correct answer in this case is very simple, it's B. Is it done? Hope so this is clear. Let's proceed to the next question, child. Now, here, child, they have given some set of reactions, and they have asked what is X, Y and Z, or basically they have asked what is Z in the reaction. So, let's try to write it. Now, the starting material given to you is what? CH3, CH2, CH2, and they have given over here as Br. Now, what do you have got on the arrow, child? I think so you have got on the arrow NaOH with aqueous condition, correct? Now, when you have got this situation, yes, what will happen? This leads to substitution, yes. So, your Br will get replaced by OH. So, will I get nothing but the answer as propane 1 all, correct? and this becomes my answer X. Now, what will happen to the next step when you have suppose given to you as Al2O3. Now, what do you mean by Al2O3? I think so this is used as for dehydration. Now, whenever you do dehydration, we need to first find out the leaving group, which is this. So, this position is alpha, and immediately from the next position your H can be lost. That means your product obtained would be nothing but a propene. Correct? This is nothing but your product Y. Is it clear? Now, last. What is the last step, child? I think so this is nothing but your reaction with chlorine water. Now, one thing is very clear, child. When a chlorine reacts with an water, correct? It reacts to give you, I think so, HOCl. Now, in this HOCl, child, your OH becomes a negative part and your Cl becomes a positive part. So, now when you have this, can I write it as HOCl, where OH is a negative part and this is positive. So, whenever if you have got an unsymmetrical alkene and unsymmetrical reagent, your negative part will go and attack to that carbon atom which contains less number of hydrogen. So, here you can have CH3, CH, CH2. Now, the negative part is, I think so, OH, and positive part will get attached over here. And I think so this becomes your option, sorry, product Z. Now, as for this, which should be the correct answer? Now, see, the correct answer, I think so, in this case is the example, your option B. I think so. Is it clear? Let's proceed to the next question, child. What we have now, child, on the next side, if you see the product formed when acetylene is heated with red hot iron tube. Now, this is one of the very common question, child. We all know how do you write acetylene. I think so this is an acetylene unit, correct? Now, we are heating this in a red hot iron tube. Temperature is 873 Kelvin, if you remember. So, such type of 3 molecules more we will take, 1 more, 2 in short. So, in all you have got 3. Now, what will happen? Since when you heat so much, your pi bond, what you can see, yes, will go and attach to the next one because of this valency disturbed. So, this pi bond will go and attach to the next unit, and because of this pi bond will go and attach to the next unit. I think so. What you will get? CH, CH, CH 6 times, having double single, double single. So, here will I nothing but get and compound formed as aromatic compound called as benzene. So, this is one of the very common reaction, child, where benzene is obtained as a product. Is it clear? Hope so. This is clear. Let's see the next question, child. What you have got on screen? When one alkyne is treated with sodium in liquid ammonia and the product is reacted with methyl chloride, the end product of reaction will be what? Now, this is one of the very common reaction. Let's see. Suppose if I take any alk 1-ine. Now, see, I have taken alk 1-ine. So, this is 1-ine. Now, treat this with sodium in liquid ammonia. Now, child, you should know one thing, that your H attached to triply bonded carbon is acidic in nature. So, being an acid, it will come out. Yes. So, what you will get? R, C, triple bond C, and whenever acid loses H, it forms a negatively charged part, conjugate base. Now, what? This H will come out, and one more unit of such molecule will give you H2 gas. So, byproduct in this case is H2 gas. And what will come in place of this? You will have got sodium metal. Now, what? This is the first part. Then they are telling that this compound is treated with methyl chloride. So, now we know alkyl halide likes to undergo which reaction? Nucleophilic substitution. So, here is this nothing but a nucleophile? Yes, Cl minus, and this is plus. So can you see over here a nucleophile will attack this carbon atom methyl. So these groups will come out as a byproduct as NaCl, and the product obtained is what? R C, triple bond C, and the new member came as methyl. So now if you noticed, yes, if you must have noticed, let's say this contains n number of carbon atom, correct? Here I think so you will have got n plus 1 carbon atom. That means in this reaction you have seen lower alkynes are converted to higher alkyne. So here in this higher alkyne is obtained having 1 carbon atom more is the correct option. Is it clear, child? Hope so this is clear. Let's now see last 2 questions. Now here, child, they have given which is the most suitable reagent among the following to distinguish compound third one from the list. Now if you see out of this 4, the third one is this one, correct? Now how this third compound can be distinguished from the other? Now third compound I think so contains an acidic H, or it is acidic alkynes, and I think so, child, if you remember while doing discussion on alkynes we have done laboratory test for distinguishing terminal alkynes, that is acidic alkyne, and for that we have got 2 tests, ammonical cuprous chloride and ammonical silver nitrate, which is called as Stollen's reagent, because Stollen's reagent will give white PPT with terminal alkynes, and I think so over here we have got a Stollen's reagent which will give white PPT with this compound, whereas for all other compound test will be negative. So the correct option for this question is D. Correct? Now let's proceed to the last question what we have, child. Now this question is again statement 1 and 2. What is this? In presence of air, the phenol mixture becomes dark color. Yes. Whereas statement 2, that is nothing but a statement 2, sorry over here, statement 2, phenol are slowly oxidized to dark color mixture containing quinones. Now basically, bacha, in this case, we can tell that when you see a phenol and when you keep it in open air, it slowly changes the color and becomes a dark. That means this statement is correct. But now question is, why it becomes dark? So I think so you understand one reaction, which is when a phenol, yes, is kept in open air, will it get oxidized? So oxidation will take place, and after oxidation will it give you nothing but para-benzoquinone, and hence these benzoquinones have got dark color. So as phenol is kept in the open air, slowly some of the molecules of phenol will start getting converted to these quinones, and hence it will result a mixture which will be dark in color. I think so in this case the option even this is also correct. So as per the discussion, both statement 1 and 2 are true. I hope, child, you are clear with this today's paper. Yeah, thank you very much.